Let us consider a suspension cable having a total span of 30 meters, and it is supported at A and B at the same levels, and the maximum dip is given as 3 meters, and this suspension cable is loaded with a 10 kilonewton per meter uniformly distributed load throughout its length. Now let us try to find the maximum tension in the cable. For that, we need to know the value of the support reactions VA, VB, and H. In this case, VA is equal to VB since it is symmetric in both geometry as well as loading. So VA is equal to VB is equal to half of the total load. Our total load is P into L. The value of load intensity is 10 and it is over a span of 30 meters. So the value of VA or VB is 150 kilonewtons. Similarly, the horizontal reaction is given by PL square by 8D. PL square divided by 8D. And our intensity is 10 and span is 30 and the maximum dip is 3 meters. So we will get the horizontal reaction at A and B as H is equal to 375 kilonewtons. So the resultant force will be the tensile force acting in the cable. So we can write that as a T max is equal to square root of VA square plus H square. So it will be 150 square plus 375 square, the whole power 1 by 2, and its value is 403.9 kilonewtons. You can also find the angle at which this T max acts with respect to the horizontal. It can be found using the expression theta is equal to tan inverse of VA divided by H. Now let us consider a suspension cable. It is supported at 2 points. Let us call these points as A and B, which are 25 meters apart. So the horizontal distance between A and B is 25 meters. The left support A, it is 2.5 meters above the right support, and the cable is loaded with a uniformly distributed load of 10 kilonewton per meters. So the value of P we can take that as a 10 kilonewton per meter, and it is loaded throughout the span. The maximum dip in the cable from the left support is 4 meters. So from A, this maximum dip is 4 meters. So from B, it is 1.5 meters, which is the value of a D2. We will find the value of maximum and minimum tension in the cables, which means that we will find the values of VA, VB, and find the value of H. H will be equal at A and B. And we will find the resultants at A and B, which will be the tension at A and tension at B. One will be maximum and the other will be minimum. And the minimum tension will usually occur at the uh, lowest point in the cable. We will start with the expressions. Since the supports are at different levels, we know the expression L1 by L2. This ratio must be equal to the ratio of D1 power 1 by 2 and D2 power 1 by 2. We also know that L1 plus L2 must be equal to the total length of the cable, or L1 plus L2 must be equal to the span between A and B. We know the value of a D2. We will find L1 and L2 from these two expressions. So we can express L1 in terms of L2 as D1 is 4 meters and D2 is actually 1.5 square root of this multiplied by L2. So expression between the relation between L1 and L2, so L1 is equal to 1.6329 times L2. I will substitute this in the total length equation. So instead of L1, I will substitute this 1.6329. So I can find the value of L2. The total L between A and B is 25 meters. So L2 can be expressed as 25 divided by 2.6329, and this value is 9.495 in meters. I know the value of L, it is 25. I know the value of L2. Now I can find the value of L1. L1 is a 25 minus 9.495. So it is going to be 15.505. The value of VA, the vertical reaction at A, that is nothing but a P into L1. Similarly, the value of a reaction at B, VB, can be written as P into L2. So the value of VA is, the intensity of load is a 10 and the L1 value is 15.505. So the value of VA is 155.05 kilonewtons. Similarly, the value of VB, the intensity value is a 10 and the span L2 is 9.495. So the value of VB is a 94.95 kilonewtons. To find H can be written as PL square by 2D. First, let us try with L1. For that, we have to substitute D1. The intensity of loading is a 10. Value of L1 is a 15.505. And D1 is 4 meters. So for this, you will get the value of H as 300.51 kilonewtons. Similarly, you can also find H using the other span also. It can be written as PL2 square divided by 2D2. When you substitute the values, L2 is 9.495 and the value of D2 is 1.5 meters. When you substitute these values, for this also you will get the same H. Now we will find the value of tension at A and the tension at B. T is nothing but the resultant of VA and H. So it is square root of VA square plus H square. VA value is 155.05 and H is 300.51. So the value of TA comes around 338.15 kilonewtons. And the value of TB is square root of VB square plus H square. The value of VB is 94.95. H is 300.51. And the value of a tension at B, this value comes around, it is supposed to be less than TA because B is at a lower level than A. So this will have 315.15 kilonewtons. Now we have the value of TA as well as TB. The maximum tension in the cable is 338.15 kilonewton. It occurs at A. And the value of minimum tension actually occurs at the point where there is maximum dip. In this cable profile, we have maximum dip somewhere. So this will have a tension which is actually acting horizontal. So this value will be equal to H. So the value of minimum tension in cable will be equal to the horizontal force. In our case, the horizontal force is 300.51. So this is the value of minimum tension in the cable, and the value of a TA gives the value of maximum tension in cable. So within the cable profile, where we have the uppermost point, there we will have maximum tension, and where we have the lowermost point, there we will have the minimum tension in the cable.